Good day, everybody. So good to see everybody's smiling faces here on this whatever day you're watching this. The purpose of this video is to walk through that first third of the TOK presentation, the extraction piece. In Google Classroom, you have a few different documents available to you. I'm going to walk through this main one here that goes over the difference between the extraction and the exploration. And then I'm going to show you a little walkthrough guide method model that you can use. It's a blank drawing in Google Classroom that you can use. It's really what you're going to be kind of turning in on Monday. You have a few options for what you get to turn in, whether it be Monday, Tuesday, Wednesday, whenever you're turning this in. But I'm going to show you at least one example that you can use, and there are alternative models and methods as well. So this video will kind of walk you through. Hopefully we can get done with this in about 15-ish minutes. And you will hopefully by the end of this be a little bit more knowledgeable on what is required for at least getting from that real life situation to the knowledge question, that first third of the TOK presentation known as the extraction. So that's what this is, the introduction to the extraction. And our goal is to get from that real life situation to a more TOK conversation. So I'm going to walk through this with you, kind of read it. Again, you have this document available to you in Google Classroom as well. So let's start here. What is the extraction piece of the TOK presentation? There are two parts, like we talked about last time, the extraction and the exploration. The extraction is kind of when you take that interesting real life story, concrete story, give a summary of that, and then you kind of ask an intelligent question about the story, also known as a knowledge question. And then the exploration is when you actually answer that intelligent question intelligently. The extraction should take about 3 to 5 minutes. 3 minutes if you're doing it individually. If you are doing it with a partner, you have up to about 5 minutes to do the extraction. The exploration is most of your presentation. That will be more along the lines of 6 or 7 minutes for most of you as you're doing it individually. It takes about 15 minutes if you're doing it with a partner. This is probably going to blow your brains out, and we're going to take this kind of piece by piece. We're only going to do this first part for today, but this is kind of what your TOK presentation looks like, all the different pieces of it. And like I said, today we're just going to be looking at this top part here, the extraction, and it might look a little more complicated than it really is. There's really only like 5 different pieces that you're going to be doing here. So that's there for you to look at the entire thing. If you want to take a look at what is the entire TOK presentation, this is what it looks like. A few definitions even before we get started so that we're all on the same page using the correct terminology. A real life situation, we went over this last time, but just a friendly reminder, it's that story, concrete story, real world events, have it be interesting. It can be from a few different places, articles, documentaries, something you saw on Netflix, news events, something that happened in the class as well. You can use that. I give a few examples there. Not going to go over those because we've already done that last class. Couple phrases here that may come in handy to kind of see the separation between kind of talking about concrete stuff and talking about more abstract stuff, stuff in the TOK world. So first order stuff is a claim about the thing under investigation. It's what you're looking at in all of your classes. So in science, if you're looking at the cell and you're saying something about the cell, that's a first order claim, a first order knowledge claim. And it's kind of the job of TOK to like go to the side of that and kind of look, okay, well, how do we know about how we know about that? How did the scientists do their job? How did they arrive at that knowledge that they have? And so first order stuff looks like in math, there are an infinite number of primes, or in history, there are many causes of World War I. That's looking at the thing itself. And then the second order claim or question, again, you go to the side and go, well, how do we know about how they got to that information or that knowledge there? So it's usually a claim or question that deals with one of the components of knowledge. You can click on those links there to refresh yourself on what the components of knowledge are: production, acceptance or testing, communication, transmission, evolution, value, access, maintenance, all that stuff. What those claims and questions look like are here. Mathematical knowledge is certain. That would be a claim about mathematical knowledge. That's that second order claim. Or for history, how should historians decide between competing interpretations? That is a second order question, kind of a knowledge question about history. So that's what we're really aiming for with this presentation, is addressing these second order things here. The knowledge issue, I call, is like the topic of your TOK presentation. You're not talking about the first order thing. You're not giving a presentation on the causes of World War I or on the conspiracy theory that you want to look at. You're really talking about kind of a knowledge thing, a knowledge issue. And it's kind of easier to show examples for this than it is to give a just flat out definition. So if you're looking at, let's take this second example here for a real life situation. Many pollsters and political pundits or analysts predicted that Hillary Clinton would win the 2016 presidential election in the United States. And so you wouldn't do a presentation about that. That's your real life situation that gets you over to the knowledge issue being about maybe big data, psychological profiling, the limits of qualitative versus quantitative methods. Like this last one, especially the qualitative and quantitative methods, would be a really cool discussion to have. That's that second order discussion of how do we gather data, what counts as data in, let's say, politics. That would be a second order conversation. That's a knowledge issue that you could look at in your TOK presentation. Another interesting one would be the rise of the anti-vax movement. You're not doing a presentation on the anti-vax movement and all the craziness that is the anti-vax movement. You're kind of looking maybe at the development of ideologies, like why do people develop these alternative set of beliefs, especially in our digital age. So that would be something you can look at. But this is these on the right-hand side of this column here, those are the knowledge issues. That's what your presentation has to be focused on and about. I gave you a list of words, a list of knowledge issues in this document here. This has already been shared with you. Like I said, you can choose one or maybe a combination of a couple of these different words, these knowledge issues, ideas. That's what you can focus on in your TOK presentation. The knowledge question, the dreaded knowledge question that everybody's afraid of because they're really, really difficult. A knowledge question is really just a question about that knowledge issue. Is qualitative methods, qualitative data gathering methods better than quantitative? That's a knowledge question. It's actually very, very easy. It's very easy if you start with a claim first, actually. So I would, if I were you, have a debatable claim about the knowledge issue. Let's say qualitative methods are better than quantitative methods. That is a debatable claim that you can make about gathering data. Then you just turn that claim into a question. To what extent are qualitative methods better than quantitative methods? So I think the best strategy to use here, and I'm going to show you in the walkthrough model as well, is to have some sort of debatable claim about a few ideas, or one or a couple ideas here, how they interact maybe, and then turn that into a knowledge question. One helpful hint for a knowledge question is that it should have the word knowledge in it, or at least have the ability to have the word knowledge in it. You don't necessarily have to have the word knowledge in the knowledge question, but it probably would help. So there's a little bit of a tip there. Here is a couple of examples for how to go from that knowledge issue claim, debatable claim, into a knowledge question here. Let's start with that second one again. Models are the best tool to help us communicate knowledge. It's a very debatable claim. We kind of have to decide, is this true? And so you can easily turn this into this question. To what extent do models help us communicate knowledge? And in the process, you can identify if this claim is true. Models are the best way to do it. Well, you would actually look at that. What are the other ways that you can communicate knowledge? What are the limitations of models? That's what you would look at in the exploration. How about this one right here? Too much data is often a hindrance in producing and communicating knowledge. It's a debatable claim about a knowledge issue. And so you turn that into a question here. To what extent is too much data a limitation in the production and communication of knowledge? So like I said, one of the best ways I think to get to a knowledge question is to take that knowledge issue claim, something that looks like this, and turn it into something that looks like this right here. There are some standard question types or question stems that you can use. The to what extent is a classic one for the IB, but you can also use, in what ways, what is the role of something, or what's the relationship between two or three things. Here is another helpful document if you want to take a look at maybe how to get from that first order stuff, from that concrete stuff, into the knowledge realm of the second order. You can take a look at that by yourself. This document right here, this little picture right here, kind of gives some examples of good questions, good knowledge questions, good things to talk about versus bad knowledge questions. You can take a look at that as well. A brief overview of what the extraction piece looks like. You start with the real life situation. You do that whole here's my knowledge issue. The contextualization is what some people call it as well. And then you finally end with that knowledge question. This is what I'm going to suggest you do for the next week. Over the weekend, you have this. Tuesday or Wednesday, you are turning this in. But you can create your own kind of walkthrough method here in a document. It is also created for you in Google Classroom, so you already have a copy of this yourself in Google Classroom. I'm going to give an example of how to use this tool right here. You do have access to this as well in Google Classroom. So here are two examples for how to use this. The human sciences example, or like politics, I went to this article here about how we predicted wrong the presidential election in 2016. Everybody got the presidential election prediction wrong, predicting Hillary Clinton. It was Donald Trump who won. And this guy is going to say we should try to predict the 2020 election anyway. Even though our models sucked in 2016, we should still develop models and try to predict who is going to win the 2020 election. So I read this article. I kind of tell the story about how Donald Trump won, even though nobody predicted him to win, how most polls, how most political analysts were way off. So I tell the story about that. Then I list some interesting questions. You can see this one here. And it can be anything. It can be first order questions. It can be second order questions. You just kind of start listing some questions, things that made you think as you were kind of looking at the story. So the questions that I asked were, why are the predictions wrong? Predictions are more, you can also have ideas as well. Predictions are more than just random guesses. There is a process involved. Kind of got that from the article. I asked this question, how is a prediction different from a theory? Because it does talk about that in the article a little bit. And talking about like the business aspect of it, there's a business in predictions. And so we kind of see this in politics, in sports, and economics. I pick one of these either questions or ideas, and then I put that up here, the thing that I kind of want to focus in a little bit more on. The thing that I found kind of interesting is this idea of what is the difference between a prediction and a theory. The knowledge issue is that actually a prediction is a type of knowledge, a theory is a type of knowledge, so that's a knowledge issue in and of itself. These two types of knowledge, so predictions and theories, is what I'm going to focus on as my knowledge issue. I then take my knowledge issue and I make a debatable claim about it. It says here, predictions and theories are two different things, and there's no relationship between the two. It's quite a bombastic claim. But then what I do is I take this claim right here and I just turn it into a question. It's kind of examining, is this true? Or kind of what ways do they interact? So I just turned this claim right here into this question, in what ways might predictions and theories interact? This entire thing right here is an extraction. I got from my real life situation, talking about Donald Trump winning the presidential election in 2016, even though all predictions predicted him to fail, to not win. And then I kind of got to, okay, well, predictions, theories, what's the difference here? Kind of make this claim about it, and finally get to my knowledge question, to which I can then launch into my exploration. Here's another example here. This is quite a funny story if you don't know anything about it. There was a guy back in around 2000. His name was Alan Sokal, and he got published an article in a journal that claimed that gravity wasn't real. Now, Alan Sokal is a physicist. He is a physicist at New York University. And he did this as a joke. He wanted to see if he could use a whole bunch of jargon, crazy language to kind of get published in this cultural studies journal, kind of showing that there's no real academic rigor, there's no real peer review process, or at least you can trick the peer review process into publishing absolute nonsense, that gravity doesn't even exist. And so there were a couple of Sokol's followers, people who kind of followed up on Sokol's little trick here, and they have kind of made this their business of trying to get fake papers published in peer-reviewed journals. They have gotten a couple crazy ones published. If you want to take a look at the article, I do suggest it. It's rather funny. I'll give you a little bit of a preview. One of the articles they got published in the journal is they did a study on dogs humping other dogs in a dog park and how this is rape and how it's ruining America. They actually got that published in a journal. And so they kind of do this, like I said, to show the limitations of peer review. And that was kind of what I started focusing on, the questions that I had about this, some ideas that I had. Does peer review look the same across disciplines? How does peer review even work? What's involved in peer review? What are the checks of accuracy in peer review? And then kind of, are there solutions even to this thing? And so all of my questions really were kind of revolving around this, is the problem with the peer review process. And that issue is really about methodology. Like, how do we test this information, this knowledge that people are putting in this paper? And it has to do with accuracy as well. How do we make sure that we're getting the most accurate information we can? So I took that knowledge issue here, and I made this debatable claim. The methods used in the human sciences to test for the accuracy of knowledge are unreliable. It's a very debatable claim that kind of peer review, one of the methods used, isn't a real good way to get us to accuracy. It's unreliable. But I then turned it into a question. That's my knowledge question. Is peer review in the human sciences a reliable way to test the accuracy of knowledge? One of the helpful tools you can use here is kind of seeing, well, what kind of knowledge am I talking about? And make sure that you're talking about knowledge. Ask the question, okay, well, am I talking about explanations? Am I talking about theories? Am I talking about ideologies or paradigms, models, predictions? If you're not talking about one of these or multiples one of these, you might be a little bit off track and might not be focused so much on knowledge. And so you have to make sure that you're focused entirely on knowledge. And so this is a good question to ask yourself, to check yourself, okay, what type of knowledge am I even talking about? It can be one type of knowledge. You might want to look specifically about the role of theories in history or something like that. But it can also be multiple types of knowledge that you're looking at. You can also ask yourself this question to make sure you're on, what like component of knowledge are you addressing in the knowledge question and in the exploration? Are you talking about the production of knowledge? Are you talking about the testing or acceptance of knowledge? Are you talking about the communication of it, the value of it? So it's a good kind of check here again, just to make sure that you are on the right track. Again, this little model, this little walkthrough step-by-step thing is available for you already in Google Classroom. There is your own Google drawing of this. You can fill this out. You can use this one. I have had a lot of success with students using this in the past. It really, really helped them kind of develop their extraction piece and end up being very good extractions for most of them. Some people don't want to go about doing it. That's okay. There are alternatives that can help as well. Here is one. I put an alternative extraction model in Google Classroom for you as well. It's somewhat similar, just a kind of different ways to think about it. If you are more of a person who wants to do like an outline, I want to see it in a Google Doc that's just line by line ABC, but that's okay as well. But I am going to really encourage you to include each one of these steps at least. So you don't have to fill out this exact Google drawing with all of the colors and everything like that. You can put it in a Google Doc that's kind of line by line, but I am going to ask you, identify what steps you're at so that this extraction piece, this first third of your TOK presentation is rock solid and very, very good. If you get this first third down, you have set yourself up for success. You really, I don't want to say you can't get below a 4, but it's really hard to get even below a 4 if you can get this piece down, this extraction piece down. So please take a look at this and kind of work through it, think through it with your own real life situation and how you're going to get through each one of these steps to that knowledge question. This is going to be due. Again, check the document or the PowerPoint where it has the different due dates for what everything is due. But this will be due for TOK 2 on Tuesday, and this will be due for TOK 1 on Wednesday. So if you have any questions, please, of course, email me, let me know. I am also sending along a Google form where you are going to tell me what your knowledge question, I'm sorry, you're going to tell me what your real life situation is. So please fill that out in conjunction with taking a look at this video, completing this extraction piece here. And the next week, we'll take a look at a couple examples, really good examples of TOK presentations, and then you'll be working on your exploration and completing some individual conferencing with me. I hope you have a wonderful weekend. I will see everybody next week. Bye-bye.